All right, so in this video, we're going to go through sample question 71 from the Society of Actuaries ExamP list of sample questions. The question reads, at time t, the manufacturing system is out of operation and has a cumulative distribution function as follows here. The resultant cost to the company is y is equal to t squared. Let g be the density function of y, and we need to determine g of y, which would be the density function for any y greater than 4. All right, so this is a classic example of a univariate transformation. Fairly simple, but really good for kind of demonstrating how to go about these kind of problems. All right, in all of these univariate transformations, you're going to be given some version of this. There'll be two functions to deal with, right? And with these functions, each function will have a CDF, right? So CDF of function 1, CDF of function 2, and they'll also have a PDF. They're going to give you one of these pieces of information and ask you to find the other, just one of these other ones, right? Typically, maybe they'll give you the PDF of function 1 and ask you to find the PDF of function 2, or in this case, they gave us the CDF of function 1. They want us to get the PDF of function 2. All right, so we need to know how all these are related. Obviously, if you differentiate a CDF, you should get the PDF, right? The density function. If you integrate the density function, you'll get the cumulative distribution. That relationship should be something you're very familiar with. Now, there are two ways you can kind of cross from one function to another. Either you can do a transformation on the CDF to go from here to here, or there's a formula to go from one PDF to another PDF, right? And obviously, these pathways can be crossed. So here we have two options, right? We're given the CDF and we want to get here. We can differentiate, get the PDF and use a memorized formula, or we can do a transformation to get our other CDF and then differentiate to get our final answer. I'm going to go with the latter pathway. So since the PDF of our second function is a lowercase g, I'll use a capital G for the CDF. G of y is equal to the probability that y is less than or equal to some specific y value. Now I'm going to transform this, right? Because we're told our random variable y is equal to t squared, this should be equivalent, the probability of probability of t squared less than or equal to some y, right? And then I can isolate the t, and I get t is less than or equal to some square root y. All right, now this is the transformation I've done. I've taken the CDF for y and I've wrote it in terms of something I already have, right? I already know the cumulative distribution for t. So what I can do here is now insert that into my actual distribution. So this is equal to 1 minus 2 over square root y squared. And from here, all I have to do is just distribute that this exponent. Okay, now it's 1 minus 4 over y, and just for ease, I'm going to rewrite this as 1 minus 4y to the negative first. Okay, so now I've used my distribution for my first function and use it to get a distribution for my second, right? All of these are equivalent, so this is equal to the cumulative distribution of y less than some specific y. Okay, so now that I've gotten the CDF of function 2, I just differentiate to get the PDF, the probability density function of function 2, which is what the question's actually asking for. So with a little bit of calculus, right? Day one calculus. I take the derivative of 1 is just, 0. This becomes minus the derivative of this goes down. So this will become -1. Right, -1 times 4 times y to the second. Sorry, y to the negative second. Just like that. And simplifying all of this, I get 4y to the negative second. There are no negative exponents in any of my answer choices. Quick conversion gets me 4 over y squared, and that is the PDF. So I should, actually these aren't equal signs. So that is now the PDF of function y. Right, so this is what g of y is equal to. Answer choice A. Okay, so remember, what are some takeaways? Anytime we have a univariate transformation type of question, right? Two different random variables, we are given one of these items, right? Either the CDF or PDF for one of the functions, and we need to get the CDF or PDF of a different function, right? Imagine these are like roads, okay? You have to cross them to get to what you want. Typically, you're going to go one of two pathways. If you're, let's say, given the PDF here, you can either, and you need this CDF, let's say, you can integrate and then do this sort of transformation. There is a formula that you should definitely memorize that can get you from a PDF to a PDF, right? However, if you don't have time to fully memorize that formula, which I really think you should at this point, you could go from a PDF, and if you're given a PDF and asked to find a different PDF, you could integrate, convert, differentiate. That's going to take a lot more time than just using this formula, even if the formula looks a bit messy. That's pretty much it. If there are any questions, leave it down in the comments below. If this video helped you out, like, subscribe, that totally helps me out. And if you want to see more questions done out like this, I got a playlist. Check it out. But other than that, good luck.